Hi, in this video I'm looking at using our graphics calculator to simulate the sample means of 100 samples from 50 rolls of 2 dice. So what that means is we're going to take 2 dice which enabled 1 through to 6, so we got 1, 2, 3, 4, 5 and 6, and we've got our second dice 1, 2, 3, 4, 5 and 6, and we want to look at the results of adding those two together. Now, if you think about the possible options, that means we have 2 all the way up to 12 as possible options. But even though all of these are equally probable, so if I think about drawing out the distribution of that, if I get a 1, it's as equally probable as getting a 2 and a 3. So we actually have a uniform distribution from 1 up to 6. But if we think about the 2 through to 12, it's not the same. So let's have a look at what that's going to look like first. So let's get up our calculator, and we're going to use our spreadsheet application to help us. So we'll go into spreadsheet number 4, and we are going to want to generate random numbers from 1 through to 6 and add them up. So if we enter in our first cell, we're going to go shift equals, and we can start typing in a rule to generate our random numbers. Now if we go to option, we can go to probability, and we can go to rand, and we're after integers because we only want 1, 2, 3, 4, 5 and 6. So we're going to get a random integer between 1 and 6, and we're going to add that on to another random integer from 1 through to 6. And if we hit execute on that, we get a possible 8. Now what we're going to do is we're going to copy this down to represent 50 rolls, because this is one roll. So that could have been 2 plus 6, or 4 plus 4, or 3 plus 5. So we're going to go up to our first cell, and we're going to go to clip down here. So we want shift 8, it's going to clip it. And we're going to make it so that it fills this through to the first 50 rows. So I'm going to go to edit here, and I'm going to go to fill. And so we wanted to fill our random integer rule, which we can see is the random integer plus another random integer. And we wanted to fill all the way from row A1 all the way up to cell A50. So it'll give us 50 rows from 1 up to 50. If we hit execute and then execute, it'll think about it for a little bit, and now we have 50 rows, all of our same data. So if I hit exit until I'm back to my normal cells, I can go down and I can see I've got numbers ranging between 2 and 12. So now let's graph this and see what it looks like. So I'm going to go around the corner here. We're going to go to graph, and we'll go to set up our graph. I want a histogram, which I've already got set here. Otherwise you could change it down the bottom here. We're currently, it's going to graph A1 to A100, but we don't want it to do A1 to A100, so we're going to edit this and go from A1 to A50, because we only have 50 cells. Press execute to save that, and we'll leave the rest of it alone, and we'll go execute. And so we'll go to graph 1, and we've got a start of 6 and a width of 2. Well, that's not going to work for us because our starting number is 2. So we'll set that to 2, and we'll put in a width of 1 because my numbers go up in 1. So if I press execute on that, we get this for our distribution of just one sample. So our single sample goes up, and it seems like our biggest possible number, well, our most likely number is about 8, and then it sort of drops off, and it doesn't seem like the higher numbers are that likely, but they are sort of mirror imaged. And so if you actually look at this, it actually kind of looks like it forms, at least on the left hand side, a triangle. The right hand side is a little dodgy, but this actually does create a triangle distribution. If we got more samples, this distribution would look like from 2 up to 12, it'd increase up to about that 7 or 8 and then drop back off like a triangle. Now let's have a look at what our 100 samples of this looks like, because we want the sample means of doing this 100 times. So let's exit out of our graph. I'm going to go across to row B, column B, go back up to the top, and we will fill in this row with actually finding the mean of getting 2 dice rolled 50 times and finding the mean of the results. So we're going to go to Shift equals, and this time we're going to want to add all of this up. So I'm going to go to List and Sum, so that way I can find the sum of all of this. I'm going to get my 2 random numbers, so I'm going to exit and go to Probability, random number from 1 up to 6, and I can put in a third argument and say that I want to do that 50 times to get a whole list of random numbers. And I'm going to add on the random integer from 1 up to 6 50 times, and close that bracket, close off the bracket for our sum, and I'm going to divide that by how many we're doing. We're doing 50, and so we press execute, and I have one mean of 50 samples, so the mean is about 7.2. So that says to me from one sample the average number that came out was just over 7. But we want to do this 100 times, so we'll clip this. So we'll go Shift Clip, Shift 8, and we'll go to our Edit, go around to Fill, and we are going to fill this from B1 all the way up to B100. Execute, and it'll think about it for a little time. So this is going to roll the die, or the 2 dice 50 times, add them up, and then find the mean of all of those rolls. And we're going to do that 100 times. So now we've got 100 rolls, which seem to be sitting around about that 6 or 7. I'll exit out so that way we're at normal. So it seems to be around about the 6 to the 8. So let's graph this now. So we'll go around to our graph menu, and we'll go to Set, and we'll set up graph 2 to do this. So we'll change graph 2 to be our histogram, and we're going to do cell, well, we don't want B, we don't want A because we're in column B, so we're going to go alpha B1 all the way up to alpha B100 because we have 100 of these. Execute, and execute to save. And now we can hit graph 2. It's going to ask us what we want to start with. Well, we saw that it was starting around about 6. So we'll start with 6, and we'll put in widths, let's say about 0.2. Execute. And now we have our histogram here, which shows that our numbers were going from 6 up to 8. And this sort of looks very much like our triangular distribution as well. Maybe if we exit out and regraph graph 2 and do a smaller width, so let's go 0.01 and do smaller widths, invalid setting, so maybe we can't do something that small, so let's go 0.05. Execute, and so now it's not so nice looking, it's sort of a bit up and down. So let's try something in the between. So let's graph it trying 0.1. There we go. So now we can see we've got a low chance of getting 8 or 6 and a bit, really high chance of getting 7, and it sort of seems to be falling up and down, and it kind of looks triangular, but it could also possibly be our normal distribution. So to comment on the results, we can see that the 100 sample means that we've got, the distribution is a little bit hard to see. We might need to do more than 100 samples to get a better answer, but we can see that it's sort of triangular or perhaps sort of normal. So there we go. To simulate finding sample means, we can generate random numbers, add them up, divide by how many we generated, and do that in our spreadsheet as many times as we want. So in this case we wanted 100 samples of doing 50 rows, so we did 50 lots of random numbers, added them up, and divided by how many, and divided by 50, and then we generated 100 rows worth of that rule. And then we can graph using a histogram. And so that's it, we're done.